Good afternoon, everybody, or morning or evening, depending on which part of the world you're in. Thank you very much for joining us on this webinar. I'm joined today with Panos Mitra, who's the chairman of MAMII, and my name's Steve Price, and I'm the program director for MAMII, which is Methane Abatement in Maritime Innovation Initiative. And we'll just give it maybe another 30 seconds or so, allow some people more to join. We're doing quite well at the moment, but give it another 30 seconds or so, and then we'll get going. Ella, perhaps you could put the agenda slide up for me. I think it's time to get going. So as you can see for the agenda, there's going to be a short introduction from myself. Then I'm going to hand over to Panos, who will do the keynote. And then we're going to have a panel session where we'll be joined with Bud Dar and Stuart Carpenter from MSC and Carnival as well. And they'll introduce themselves when we get into the panel. Okay, so perhaps I could just start by giving a bit of background. And if you've got questions, by the way, that come up during the session, feel free to add them into the chat. We'll do our best to answer some of them during this, but I suspect most of them will end up coming out afterwards, but we'll have quite a bit of follow up. So do feel free to put any questions in that you've got. So just a bit of background really for the Safetytech Accelerator before we get into the actual program itself. Obviously, innovative digital solutions such as artificial intelligence sensors are really the keys nowadays for unlocking productivity, mitigating risks, gaining global market advantage, and also achieving sustainability, safety, and resilience in an organization. And while these amazing technologies offer great promise, choosing them can be really quite difficult. You know, which ones, where to invest your time and your money, especially within our industry in the shipping. Working with partner like ourselves who understand the industry and the nuances of technologies and operational environments can be a very effective way of doing this and shortcutting. And you'll see when we get into the methane abatement program how that's worked. The Safetytech Accelerator was started in 2018 and established by, effectively founded by the Lloyd's Register, and with the world's first technology accelerator focused on safety critical industries. And our objective, if you like, is to streamline and accelerate technology innovation journey for organizations who are our clients, and with the objective of basically making the world a safer, more resilient place. To do this, we empower corporates and tech companies, institutions, regulatory bodies, governments, and to harness this cutting edge and latest technology. And partners choose to work with us because we're really good at solving challenges, shaping technology strategies, and running these end-to-end innovation labs like MAMII. And that's really enough for me for a background, and I'll join you again in a minute when we get into the panel session. But now I'd like to hand over to Panos.
Thank you, Steve, and thank you for the nice introduction. So, after carbon, methane is the most important greenhouse gas emission. Its importance is amplified by its potent nature. This means that despite the fact that only small quantities of methane escape to the atmosphere, the impact on climate is considerable. Methane emissions have been a ground for debate and discrediting the use of LNG as fuel in maritime for years. This in many occasions led to ship operators being penalized for making a cleaner choice. More than 2 years ago, a group of maritime organizations led by the Safetytech Accelerator decided to initiate this effort. This alliance, MAMII, in order to explore both the nature and magnitude of methane emissions in maritime, and our objective has been to put the science behind our work and claims, assessing solutions and technologies in addressing the problem. Our perspective remains intact, and I would add that this applies to every option or solution available to the maritime transition. Let's distance ourselves from the political debate. Let's use technical and scientific arguments to assess the extent and the risks of the problem in detail. We therefore embarked on this journey on the basis of one fundamental pillar: assessing the magnitude of the problem for all emissions, all types of emissions, from maritime, irrespective of origin, from well to tank, while at the same time we would also be working on the solutions or guidelines to tackle the full range of methane emissions. We committed practically to not leaving anything behind. This report distills approximately 2 years of work. Its objective is to provide conclusions, but also steering for ship operators, regulators, and stakeholders on the next steps to address methane emissions in maritime. It covers 5 key areas: well to tank, tank to wake, measurement, reporting and verification, methane abatement, and cost-benefit analysis. It provides outcomes of MAMII works and directions ahead. Among its key conclusions, we can highlight the need for a technology-centric, incentivizing regulatory framework with clarity on how improved performance can be credited. The need for the maritime industry to take initiative and source cleaner, methane-proof bunkering value chains. But we also have been intrigued by the depth, the number of technologies focusing on abatement. So methane slip, we understand, and it's one of the key conclusions of this study and report, that methane slip should be in our greater focus now, keeping in mind that for any new application, technologies that can ensure minimal methane emissions are already available. MAMII serves as a prime example of the maritime industry taking the transition challenge into its own hands. We are actively involved in every aspect, crafting a strategy and facilitating technology development based on scientific evidence and the industry's insights. For the MAMII partners who recognize the significance and complexity of addressing a critical challenge like methane emissions, the only way forward is together. And with this final point, I would turn over back to you, Steve.
Thank you very much, Manos. That was really interesting. Just one more thing on MAMII before we get into the panel session. I mean, we started off with 7 members over nearly 2 years ago, and we now have 21 members, and we have everybody from fuel users, like today, obviously on the panel we have MSC and Carnival, but also we have people who are moving LNG around the world. We also have some of the oil majors as well, and we tried to be inclusive to make sure we get everybody's understanding and everybody's on board, because this isn't something that one company can solve. This is something that we need to collaborate together to make work as an industry. And now what I'd like to do is ask our other panelists to join us, if they would, please. And we're going to start with some broad sort of questions, if you like, around LNG itself. Why is LNG important as a fuel? Why is it shipped around the world? And why have we chosen it to be a marine fuel? So perhaps we could start off with that's basically where we're going to go first. But before we get into the detail, perhaps I can ask Stuart maybe to introduce yourself first and tell us a little bit about yourself, and then Bud, you can follow, please. Thanks.
Good morning, good afternoon, everybody. My name is Stuart Carpenter, Senior Director for LNG Implementation at Carnival Corporation. Carnival has 9 cruise brands operating globally around the world, currently of which 5 of those brands have LNG fueled cruise ships. So as of today, we have 10 LNG cruise ships in operation running on LNG around the world. As a corporation, we started an introduction to LNG back in 2015, so just over 9 years ago, where we had the first cruise ship that was fueled by LNG indirectly, because it was we had an LNG fueled barge. which then provided shore power to the AIDA Sol in Hamburg from 2015. 2016, we saw the introduction of our first LNG fueled ship while it was alongside. Prior to the introduction of IGF code, we were not allowed to carry LNG inside in accommodation spaces. So we, for a year and a half, 2 years, we had 2 LNG fueled cruise ships provided with LNG import. And then in 2018, we saw the first introduction of a fully fueled LNG cruise ship. That was the Ida Nova, and Safetytech LNG in Tenerife in 2018. So Carnival obviously moved into selecting LNG as a primary fuel to tackle local emissions, SOx and NOx. And now as we continuously use LNG now as part of our decarbonisation strategy. We see this as a fuel that's in transition. It provides us with the good framework for continuing to decarbonise the fleet going forward. And we have more of these vessels on order. It provides us with a very good basis now for decarbonisation in the short term, but also moving forward to use the likes of bio-LNG and synthetic LNG for decarbonising further in the future. Myself, I've been at Carnival now for just over 7 years. Previous to that, I spent 5 years working at Shell and also 10 years with Lloyd's Register, having wide experience of LNG carriers, but also gas fueled ships as well.
Thanks very much, Stuart. Bud?
Yeah, thank you very much, Steve. I'm Bud Dar. I'm the Executive Vice President for Maritime Policy and Government Affairs at the MSC Group. For those who may not be familiar with us, we are the parent company for MSC Mediterranean Shipping Company, which has approximately 830 cellular container ships, but actually some other types of ships too, as well as some bulk carriers, some car carriers, and a couple of conros in our fleet as well. And then in addition, we have different divisions where we operate a couple of dozen large ocean RoPax ferries. We're the 3rd largest cruise line in the world, operating 23 modern cruise ships and other enterprises on the water, including towing, that have significant footprint. So basically anything that the industry's trying to deal with, we're dealing with as a company. And so we're kind of a good microcosm as the overall industry. A couple of words about myself before I talk about what we're doing. I started my career as a naval nuclear engineer in submarines. And then after that, I went to the U.S. Merchant Marine Academy and was a deck officer. Graduating from there, I graduated at a time when there were no jobs going to sea in the U.S. flag fleet. So I ended up instead being in the U.S. Coast Guard, where I had a really career that I enjoyed tremendously, where I started as a ship inspector and casualty investigator and got to see different ships every day. And then ultimately they sent me to law school, where I was involved in international operational law, which involved a lot of IMO work and a lot of regulatory work and enforcement work. And that led to 7 years after I'd retired from the Coast Guard with the Cruise Lines International Association, where I led the maritime component of what they do. And then for the last 7 years, I've been proud to be part of the MSC Group based in Geneva, Switzerland. So what we're doing as a company is we see that we're going to need a range of molecules on the table for everyone, or there won't be enough. And also, one size doesn't fit all. If you look at the profiles of ships, the lifespan that they have left in them, the deployments that you intend to make, and the availability of fuels, you might logically come up with different answers for different iterations of how you put those pieces together. But we did not start as early as Carnival did. I think they deserve a lot of credit in the LNG space for committing big as soon as the standards were developed at IMO. That took us a little bit longer to commit, but we started with a couple of cruise ship orders, which take a significant amount of time from conceptual phase to delivery. And now we're to a point where we have over 20 LNG fueled ships on the water between our various business entities, mostly cargo ships, although we have 7 more cruise ships on order for LNG as their principal fuel. But we also have 100 container ships still on order as well. Now, we're not making a big commitment towards LNG today because we think that's the only answer. That's not the case at all. We think all the 3 major molecules and potentially some other solutions have a lot of potential to help solve this problem. But the reality is, if you want to put molecules on the ship today at scale, you can make a modest difference with fossil-based LNG, and as you migrate on to bio and synthetic LNG, which we're working on every single day to make that transition, you actually can have a long-term solution set there for those ships, while we take time to examine the other issues in light of the practicalities of fuel availability, because it doesn't do us a lot of good to build real life tangible ships that have to run on imaginary fuels that don't exist in the marketplace yet. So we kind of have to work with what we have. And then also, if you keep in mind our scale, while 100 ships might be a huge number for many other companies, for us it's less than 1/8 of the overall fleet size by number of ships that we have in our container fleet. But nonetheless, that's the direction of travel we have right now. And also, not do you just get the benefit for greenhouse gases, which we believe on a well-to-wake basis, particularly with a two-stroke high-pressure engine, you get a substantial tangible benefit today. You also, when you talk about the localized emissions of SOx and NOx and fine particulates, you get really significant tangible benefits. So we see it as making a lot of sense as a step, and time will tell where the real fuel availability picture plays out. Thank you.
Thanks very much, Bud. I mean, I think both you and Stuart have sort of answered the question, why do we use it as a marine fuel? We talked about the local particulates, and I'm guessing the cruise industry in particular, that's very critical, because you're quite often parked in very busy cities. And so basically, there was the green agenda that started that. But maybe I can widen the question a little bit, and maybe Panos, you can stay this one, which is, so why is LNG an important fuel in the world generally? I mean, why are we shipping it all around the place? What's causing this? What's the reason for it?
So practically LNG is the cleanest fossil molecule available at scale, and this constitutes part of the energy mix of many countries around the world, including developed countries and decarbonization focused countries like Europe, but it also constitutes a key energy security and growth molecule needed for countries in Asia Pacific and other parts of the world, especially. As far as maritime and its maritime use is concerned, I think that this element has been covered very well, apart from the fact that we can attain under certain conditions an overall saving of 20 to 25% by using LNG. The local pollution factor should not be discredited. So we need to keep in mind that NOx, the lethal emissions, can be substantially reduced by the use of LNG, and evidently SOx and particulate matters are practically extincted to a large degree. So the reasons are there. I would add also perhaps something that is coming today in our thoughts, the fact that LNG will in the future be more compatible with carbon capture technologies. So that is also its compatibility with the carbon negative space and carbon negative technologies may also be an additional factor to consider LNG and use LNG.
Okay, thanks. So we've talked a bit about why LNG is important, but maybe we need to talk about the problem of methane now. So so perhaps we could start off with a little bit more of an explanation of methane slip versus perhaps the other emissions that might occur, and then maybe we can after that get into what the engine manufacturers are doing in this space as well. So perhaps I don't know who wants to start with giving us a little bit of tour around methane emissions.
Should I go?
Okay.
Maybe I'll take that one first, and Stuart, hand it over to you. We didn't work out a secret gang sign to flash to each other in advance. But I think that, first of all, the first thing I'll say is there is lots and lots of rhetoric around methane emissions. And kind of a dearth of real meaningful data as to how we're actually doing and how effective mitigation measures will be. So that's why I think work like what we're doing through MAMII and also the Green Ray project, which we're also involved with, are really valuable, because I think what's not needed are more, unsupported statements or hysteria, but rather actually data supported science that can be relied upon to really paint an accurate picture of what we have. And the first thing I'll say about methane in general is anyone who's serious about using LNG needs to be serious about the methane issue. I mean, we can't kid ourselves here. It is, substantially, depending on whether you use the 100-year or 20-year global warming potential, where you get wildly different results in the math, but it is significant even at the either end of the spectrum, the 100-year or the 20-year values. And so it has to be addressed. You have to take it seriously. And you can't just take it seriously from tank to wake, which is largely what we're experts in here in this group. But there's a whole other component of well to tank that the energy providers need to address. Now, if they don't, I think there's a much bigger problem here, because society needs LNG and they need bio and synthetic LNG as well for other power needs. And keep in mind, although we think we're the most important 4% of energy consumption in the world, we're 4%. We're not going to drive the energy markets on our own, and we wouldn't see the massive development and transport of LNG if it wasn't very much needed in other places. If they don't solve that upstream component, which is probably harder to measure, probably harder to certify, harder to quantify, but they know how to do that, they will have a much bigger problem on their hands with solving the rest of society's energy needs. So I believe that the work they're doing today will pay off downrange, but let's not forget about that, because it's important for us as well as important for all of society for methane to be a molecule of choice for the future, no matter what its source, because you do have that issue, even if it's a bio or synthetic version, though you do have some offsetting factors in there which help. So what we're doing is working very closely with the engine OEMs, and what we found is once we made that a priority for them, they made tremendous progress, actually very, very quickly, to the point where with a 2-stroke high pressure engine, I mean, it's really nominal, almost completely gone, and we're seeing great advancements in the 4-stroke medium speed engines, even of the low pressure type, which tend to be the worst performing with regard to methane slip. We are making big advancements with both engine controls and in-engine abatement technology. Now that they've made it a priority, we see a big difference. And one of the mismatches we have in the various arguments that are floating around out there about the viability of LNG is that a lot of the data that's being relied upon by those that strongly oppose the use of LNG in any form is data that's drawn from earlier generation engines where this wasn't a priority. And now that it is a priority, I think you'll see the data is quite a bit different. And particularly with the 4-stroke engines, I think the Green Ray project, at least our experience with our data, is it's considerably better than the default values, for example, that we see in Fuel EU. So I'm very optimistic about the shorter term, because the molecule is here, we can use it, and we can find through mass balance anyway, some bio to use. I think synthetic will come over time, and it will be driven in large part by the rest of society's energy needs, that other 96%, which is helpful for us. But we have to do it responsibly, and we have to stay on the engine OEMs to make sure that we're connected with them and continuing to make as much progress as we possibly can. So I'll leave it at that and turn it over to Stuart.
Thanks, Bud. So yes, one of the key things that we've seen since we started down the LNG journey, one of methane slip has always been in the picture. It's never been one of those activities that's some people describe it as a Achilles heel, but it's always been on the radar. I mean, we contributed to the SGMF Sophia study back in 2018, and it clearly highlighted, even including methane slip, that LNG provided with you some net benefits to the reduction of carbon. In terms of what's on board, we have multiple generations of engines now. We have the generation of engines that was on board our ships in 2018 and 2019, and compared to what was on board the ship in 2015, was a massive step in terms of not only the ability to control the engine, but also to reduce the uncombusted methane that went through. Jump forward now to 2024, we've got brand new Wärtsilä engines on our recent Sun Princess, and as Bud said, the numbers that we've seen these are from the testbed data only at this point, but that's significantly better than the numbers in Fuel Maritime. We've done a number of studies on board, and one of the reasons that we joined MAMII was when we started to look at the challenge of measuring methane slip accurately and consistently on board. It became apparent that there were different manufacturers out there providing different types of technology. There was no baseline, no standard. One engine manufacturer would do it one way, one consultant would do it another way. So that's the challenge that we've had for the last couple of years, and is really understanding how to measure and then what technology is available. And that's where MAMII and through the Accelerator program has been very, very useful in identifying some of those OEMs who have got technology available, helping them to scale up to really start to tackle the problem. Because until we can accurately measure on board and challenge some of the data that's being put out by other parties, we can't start to tackle the solutions. So that's really where we've been for the last 2 years, is driver measurement regimes, and then looking at the technology that we can actually tackle the emissions to capture it and reduce it. So firstly, improvement to engine technology to reduce the slip in the first place, and then what technology is available to mitigate it in the exhaust side as well.
Steve, if I might offer just one more follow-up comment to Stuart's comments, and I think he did a really good job of laying out some of the history here and why we're doing what we're doing. This business overall of shipping is a business of problem solvers, and if you don't like challenges, you don't like problems, you're in the wrong business. And this is one that is a very important problem to solve. And rather than just talk about it and argue, this group, MAMII, I think very much to their credit, is narrowly focused on how can we measure consistently, how can we build a reliable data set that then you can draw meaningful conclusions from, and most importantly, how can you actually solve the remainder of the problem? I mean, that's a great thing to be a part of when you're not infected by the politics of the day, but you're really just trying to solve what I believe is a solvable problem through proper enthusiasm and resourcing and expertise.
Thanks very much, Bud. Panos, measurement came up in that conversation. I think it's really, really important. What's your thoughts on that and where we are now?
After this continuous work, and further to Stuart and Bud's comment about measurement, the key thing here is we have a heritage of regulating emissions, and it seems like that methane so far has been an exception. In what sense? In the sense that there was a quite heated political debate about what is the exact what will be the exact methodologies to use, and there has been a great variety of studies, and I would say great variety of outcomes in terms of figures, and we realize that one of the key reasons why we see this inconsistency is the lack of a universally accepted protocol measurement methodology for methane. And we, as MAMII, I think we all partners realize that it's a top priority right now for the whole industry to set up and establish a universally accepted methane measurement protocol. Without this, crediting performance and improvement will be impossible, and this means that also investment and incentivization of technology development will also be impossible. On top of this, let me add that we know that IMO is now working on this with a correspondence group dedicated focusing on the measurement of methane and nitrous oxide, and we need to keep in mind that since these two emissions are critical not only to methane but also other promising options without a measurement protocol in place, without an established methodology to measure and certify performance, we will not be able to assess the exact benefit of all these solutions, of all these options. And I think it is right from MAMII's side to voice that as a key priority for the industry.
Thanks very much, Panos. Perhaps I could just pick you up on one more thing, Panos, which is earlier we mentioned, I think Bud mentioned the fact that this is all very well, but at the end of the day, the actual bit on the ship is a relatively small amount compared with what can happen in the well to tank. What's the strategy for that?
So based on also the experience that we had and the studies that we carried out during all this work on diagnosing the problem in MAMII last year, the key outcome with respect to the well to tank side is that the technology is there. So there is practically, I would say, no excuse for majors and producers of gas to claim that these cannot be measured. So today we have assessed from satellite surveillance to sensor technology that can be really sensitive and practically sort out the problem. And at the same time, we see certification methodologies and certification capabilities being available. So we could say that the key thing here from a maritime industry perspective is to source practically the cleaner value chains, to identify, certify, and use the cleaner value chains as far as methane performance is also concerned. So based on that, this is not where we are now, but we believe that if the maritime industry pushes for certified methane performance at the manifold, this will be something that will be possible in the years to come.
Yeah, and maybe to Stuart and Bud, I mean, how important is the certification here as part of your decarbonisation strategy? How does it fit in?
Well, I'll start by saying pretty much all of the options for the major greenhouse gas regulatory proposals that we're looking at rely upon a certification scheme that has integrity and has the confidence in governments. It simply won't work without it, because most of these molecules that we're going to rely upon, ammonia could be an exception, downrange, but nothing's 100%. Get most of the benefit from the upstream side of the equation here. And so if you don't have a reliable certification scheme in place, you really can't ever make that work. So I think it's an absolutely critical component. And also, today, and I think we're going to see this situation for a while, that until we have widespread availability of the molecules and a much stronger midstream infrastructure than we have today, we're going to very much need to rely on mass balance or book and claim, should the regulators be willing to accommodate book and claim. And certification is at the very heart of making that work. And if you think about it from a greenhouse gas protection standpoint, it's a much better solution, because you probably eliminate a significant amount of the scope 3 component of that particular set of molecules, because you're not transporting it as far, or at least not to a place it doesn't need to go. And so you probably have a better overall greenhouse gas emission profile for any given, kilogram of fuel than you would if you put the physical molecules in the tank. And as a practical reality, we're a long ways from being able to actually have the biogas physical molecules put on an LNG fueled ship right now on a routine basis. We're very reliant as a practical matter on mass balance. And the other thing that I would say to argue for that, again, making certification very important, is to get the availability at scale. although startups play a really important role here, and I congratulate everyone that's shown the courage to go into startups in this business. Until the energy majors are really in, I'm not sure we're going to get the scale that's going to be required. And whether you're talking about incentivizing a startup or incentivizing the majors, you need to aggregate a demand signal, and you will aggregate much more demand faster if you can rely upon certification, either through a mass balance or book and claim system, than if you have to wait till the day when only the physical molecules that go on the ship might count for credit. So I think certification is absolutely critical here. A reasonable, best estimate that maybe can be adjusted over time with regard to the life cycle analysis that underpins those certifications is also a critical component. And I want to give some credit to the EU here. IMO didn't have to start from ground zero. IMO actually had a pretty good starting point to work from in their work, because the EU did put in some work on what I think was a quality product that they then submitted to IMO for them to consider on that life cycle to be then incorporated into certification. Thank you.
Okay, thanks very much. Stuart, do you want to, is there anything you want to?
Yeah, I mean, just as Bud said, it's critical that when we have an idea of not just the emissions that we have on board, but the quality in terms of the scope of carbon of the fuel that's coming on today. So in terms of fossil-based LNG, not all fossil-based LNG is the same. So it's not, in moment, Fueling Maritime does not recognize more locally sourced LNG, but that's something that we're working with certain partners. There are areas in Europe where methane is extracted from the ground locally, isn't transported. So to get traceability from where those molecules come from to where you can use them is an important step forward. One of the activities, and then obviously once you've got it on board, we have to have a look at how we can consistently measure that. Without a consistent standard, as panel says, then this essentially will go into your Fueling Maritime penalty, and the size of the penalty is directly proportional to the amount you're consuming and therefore the amount you're emitting. So if we are going to make strides to improve any engine technology, that has to come from science-based and physics and from a measurement point of view to demonstrate what we have now, and then actually so we can quantify that reduction in the future to limit the penalty that we receive from Fueling Maritime. So it has to be consistent. We can't have one method of testing engines at the factory, put them on board the ship and find it different. And then with a fleet of vessels, you need some consistency across the different vessels in your fleet as well, so that you have one way of being able to determine, engage with your verifiers and ultimately the flag administrations to work out what the size of that compliance is going to look like going forward.
Perhaps I could ask the three of you sort of more of a technology question. I mean, through MAMII now we've seen technologies of measurement and for me measuring methane slip and technologies for abating methane slip. And now we're also getting into the fugitive emissions, which is the temporary leaks and things that sometimes occur, and how we can detect in those and measure those. Would you like to just give me a 30-second on what you thought about the technologies that have come up and etc.? I don't know who'd like to start. Panos, do you want to?
Yeah, why not? So first of all, I need to highlight the fact that when we started this effort, we have not expected that we will come across a so pluralistic portfolio of technologies, whether it is about MRV or abatement. We have seen more technologies available that can contribute or really solve the problem. So we have come across catalysts. We see now a number of technologies in catalysis being used and tested. Evidently, there are issues still with, for example, the sensitivity of catalysts to impurities. But there's tangible work on addressing this. And at the same time, we see also the prospect of plasma, and evidently there is energy involved in plasma, and there will be energy demand, which means that there will be cost. But we see manufacturers working in combinations of the two technologies, and on top of this, we have other potential solutions, like, for example, hydrogen blending and hydrogen blending solutions. And what could that mean to methane slipping from combustion? So I would say, personally, I feel after all this work with MAMII, I feel substantially, significantly confident that perhaps, if I may, by the end of this decade, we will have many more tools in addressing the problem than what we do today.
Okay.
And just to add what Panos said, because if we think about it from a practical sense of view, if we're ordering ships now, these are the 2030 vessels. So anything that we're ordering now, we need to have a good idea of the technology, even if it may not be immediately available, and that could be put on board a ship as of today. Then we need to have a really good idea of what those companies and technology solutions look like that can be invested in, that can be piloted, such that when we really do have these key dates in the future, that we know what technology is available and can be fitted. Retrofits bring their own unique challenges, especially for different types of fuel chips. But for the new builds, for sure, now we really need to understand what is available now or could be available to start speccing them. And that's where we've really seen the benefit from the companies that have come forward to MAMII to make the presentations. Some of these are ready now, some of these are almost ready, some need some investment and assistance to get there. And it's a really unique environment to be able to contribute to that. Gives them the user's knowledge on how these can be used, what's practical on board a ship, such that we can collaborate and work together to bring the new technology to the forefront. Because none of this is going to work with just one company. We need ship owners on both sides, supply and demand, working with the energy majors, working with the OEMs to really understand what solutions can work and how we can work together to accelerate their introduction.
Can I add something to that, Steve? We know today we have achieved, I would say, a key milestone target for any kind of technology. We can attain approximately 1 gram per kilowatt hour methane slip under certain conditions, certain loading. So it's important to distinct two elements here. One is optimum engine performance, which can be fairly low. And on the other hand, there is also the fact that across the loading condition of the engine, the loads of the engines, then the performance may vary. So there are technologies out there that can practically make the performance of the engine more steady during different loads, etc. And we can consider, for example, not using an engine at low loads by having an energy buffer like a battery, or other practical, more practical solutions on how we can generalize the optimum performance of the engine across different loading conditions. So there is a pluralism of potential solutions that should not be overlooked, and we should not overlook, for example, solutions like PTO shaft generators that can really use the top performance of high pressure engines to produce electric loads on board. So all these options make us consider and conclude that technology to make methane slip minimal today is available, and there are more options that can work in combination, in conjunction together, so that we will have cleaner and cleaner applications on board any types of engines and ships.
But
Yeah, so I think Panos and Stuart have made excellent comments that I associate myself with. Panos mentioned the one technical component I was going to add, which is I do think it's important that we consider the wide range of load conditions that any ship might face. And that's where, I made the comment earlier about there's really no one size fits all solution for decarbonization. And when we look at this problem, it's one example, because, for example, if I have 4, 5, or 6 4-stroke medium speed engines on a cruise ship, I have a lot more flexibility, particularly if I throw in some hybridization or a large battery bank on its own to maybe work on peak shaving, I have much more opportunity to run the engine at its optimal load condition than I do if I've just got basically one large slow speed engine. But there are electronic means such as skip firing and things like that that can make a difference in engine technologies. And I do think that there's some potential for some abatement as well that can be done mechanically. But the main thing I'll just reemphasize is I think Stuart's point about collaboration is extremely important. I'm known to have stolen a particular phrase that Knut Orbeck Nilsson said at North Shipping last year when he was asked, what is the fuel of the future? Because that's what everybody wants to know, right? What is the one single answer? And he said, well, the only one single answer is collaboration. And I think that's right. I think it's really essential, and it weaves its way through all of this. But I do think that we're making a lot of progress because of that. Groups like not only MAMII and Green Ray and the specific work they're doing, but also the Society for Gases and Marine Fuel, which has an fuel agnostic mandate, and CLNG, which has a more specific one, are really reaching out across various parts of the sector that can contribute to the solution set here. And I think it's extremely important, and it's extremely important that we consider the overall load profile that we're going to face. And Panos's examples, I think, point out how you really run the risk of staring at the center of the donut instead of the entire donut if you're not looking at a power generation on a ship holistically, because a lot of the things he mentioned that will make a difference here in methane slip are really about how you manage the load, and that may not have anything really to do with LNG or methane, but maybe broader considerations of how do I operate the most efficient power plant on board the ship. And I think we really do ourselves a disservice if we look at any single component. And I think you really need to more and more place an emphasis on how does it all fit together to improve the energy efficiency and the emissions profile for any given ship.
Okay. All right. So I think we're really getting near the end now. So what I'm going to do is really ask the three of you to just give some concluding remarks, I think, on the end of this. But maybe as part of a starter for that, the question I'd have to ask the three of you, are you confident that we can remove methane emissions from ships so that they can be part of a decarbonised strategy as a general theme for your roundup? Panos, do you want to go first?
Yes. So as far as the removing methane emissions from ships, I think that we can and we should remove methane emissions from ships and give the LNG fueled fleet the opportunity to comply, and on top of this become an option and perhaps rebrand itself through the new variants of bio LNG and synthetic LNG that will be available in the forthcoming years. So we believe that based on also the work we have done, technology to control and measure and verify methane emissions on the well-to-tank basis is there. It's a matter of application, it's a matter of additional certification schemes, it's a matter of the development of all this certification methodology. But we think that the well-to-tank side can be tackled, especially under the initiative and the greater focus of the off-takers of LNG, and this does not apply only on shipping. On the other hand, operational emissions, as far as fugitive emissions are concerned on board the ship, the same comment applies. The technology is there. We can address the problem in the years to come, as we will be incentivizing and more or less quite soon regulating fugitive emissions as well. We will be able to monitor emissions on board. Finally, as far as methane slip, I think we have covered a lot. We need to keep in mind that for merchant ships, as far as the use of two-stroke engines is concerned, a solution that can provide practically zero or minimal methane emissions is already available, as well as the technology to make sure that we will have electric loads at the same performance. So having all this in mind, I think that we should now focus in the forthcoming years in developing more technologies that will be inclusive of all engine technologies. So once we will have this in place, I think we will be able to claim that we will be leaving the methane emissions issue behind, and it will be an issue of the past. And I think this is what we should be doing with any challenge in the maritime transition space, whether it is a risk challenge regarding an option or an emission challenge. We need to be working, tackling this and leaving this behind.
Thank you very much, Panos. Stuart?
I mean, from Carnival's side, we've had a strong focus on operational releases since day one. So from our side, those are minimal, if not near zero already, and that has been the case for the last 6 years. That coupled with then improvements in engine technology and I believe some sort of abatement. I don't think we can get it to absolute zero, but it will be negligible. But again, that's the journey that we're on. So overall, and then if the energy majors and the supply can work on the same upstream elements as well, then we can reduce the methane slip emissions to atmosphere across the whole value chain. Then it will continue to LNG and bio and synthetic will continue to play a large part in the decarbonisation of shipping going forwards.
Okay, but
Yeah, so a couple of things. One is I think LNG, despite what the opponents may wish for or say, I think it's part of the energy transition future any way you cut it. And I think that's particularly true as we move on to greater availability in the market of bio and synthetic, and we see the right signs that this is coming. And the more ships that are available in the maritime sector to actually use those fuels, the more of an incentive there's going to be to provide that for within our sector. Now, I think we need to, look for a embracing of that same pathway from shoreside users, which account for a much greater proportion, exponentially greater proportion of the usage of LNG. But I think that will come. I think it has to if the world's serious about decarbonization. When it comes to MSC, we, like I think any responsible ship owner, feels that if you're committed to LNG, either in fossil, bio, or synthetic, or a continuum of those three forms to be part of the solution here, you need to be equally committed to working towards eliminating methane slip and fugitive emissions throughout the supply chain and consumption of those fuels. And I think we've done a great job working together. There's still more work to do, particularly on the four-stroke engines, but we've done a great job of making a huge amount of progress on the shipboard component of that. And I think we've made it clear to the energy providers, and we need to continue to make it clear. They've got to match us with their efforts on their side, but I think they will do that. These are solvable problems, in my opinion, and I believe we will get there. I believe LNG will be part of that, and bio and synthetic are really very much a longer-term solution when it comes to methane. And pulling together in the same direction, I really believe we can get there. At the end of the day, this isn't about who says the best thing or who puts out the best press releases or sustainability reports. This is going to be a judgment on success or failure on all of our parts of did we actually decarbonize? And I'm one who believes we can, but we have to continue to redouble our efforts and pull together in the same direction to bring the solutions and the fuels, which is really the key here, to the marketplace at scale so we can all join together on that common goal. Thanks.
Thanks very much. And I'd just like to give a few more words before I thank the panels. I'd like to say that the MAMII program is, we're 2 years in, and obviously you can see from today, and if you go down onto the link, and you'll find you can download the public report. Obviously, this only contains a very small amount of information compared with all the information that's in the actual program. From where we are at the moment, we still have a number of significant challenges ahead of us. I mean, the technologies we're talking about need help getting out there and getting piloted, getting marinized. At the end of the day, a lot of these technologies have come in from non-marine, and and they still need work. And so we'd encourage you, if you're if you're an LNG fuel user or part of the LNG supply chain, to come and join MAMII. We'd still love to have you all on. And as I said, we're maybe halfway there, I don't know, but something like that. But we've still got quite a way to go, and we'd really appreciate more people joining us and making the most of it. From the Safetytech Accelerator's perspective, I'd like to thank you very much. And MAMII is one of our larger programs. We have a little one called Cargo Fires and Loss for those who are in container shipping and are interested in early detection of cargo fires, etc. in that space. And well, I'd like to thank now our panelists. Bud, thanks very much. Really appreciate all your wise words, and likewise Stuart and Panos, who obviously is LR's LNG gas director and also the chairman of the program. So thanks very much, everybody. And thank you all for listening. I know some of you had some questions. We weren't able to get to them, but we will pick them up afterwards and we'll drop you a note. And thank you very much. And thank you again, gentlemen.
Thank you.
Goodbye, everybody.
Thank you, everyone.